already, so we need to make sure we really understand that component. We'll also do perspective drawing in here. Okay? And if you've never done perspective drawing, you're going to love this. And if you have zero artistic talent, you're going to love perspective drawings. That's me. I have zero artistic talent, and I love perspectives because I can create a real eye-pleasing drawing through mathematical techniques. Okay? And that's going to really kind of be the main focus of that course. This will still be done in a two-dimensional arena. After that, we're going to go to solid model. Okay? We're going to spend 3 weeks in that one. This is really kind of where the industry's going. We will use AutoCAD for this. Now, we've already seen a little bit of 3D modeling in Revit. We did that a little bit last week. We'll do a little bit more today. I'm always going to use a program like AutoCAD when I teach solid modeling because it does the basics. Okay? When you did Revit and we drew a wall, you really didn't create that 3D model, right? You just drew a line, and it created it for you. If you're going to do modeling in AutoCAD, you've got to understand how the extrusion process works, how we use P-lines and stuff to make these shapes where we represent real items. Okay? And so we will use AutoCAD in that. If you can model in AutoCAD, you can model in anything. Okay? Because it is the basic methods of how we use it. Okay? Well, now, once we do that one, this class is going to take a shift. Okay? We're going to go to architectural first. In essence, this is going to require a lot more research by you because there's really no way for us in 6 weeks, 6 credit course, to go through all of the things of architectural. Okay, so if you're going ahead and designing a home, you say, hey, I need a skylight in there. Hey, we're not going to cover skylights. But that doesn't mean you won't. If you say you want it, then you're going to need to, and I can direct you on this, you're going to have to go to a vendor website, you're going to have to see what the materials are, how to install it, how to draw it, maybe drop their drawings down, and give the information for a contractor to install this thing and purchase the right one. Okay? So you're going to have to do a little bit of research in this. Okay? We'll basically do a residential home from start to finish. We're going to start with a bare lot. We're going to go out and survey it. We're going to do our site plan on where it's going to be located. You're going to size the footings for it, so there will be some math that goes with it. You're going to size the joists. We'll then build the walls, determine our interior spaces. We're going to go 2 floors because I got to get a set of stairs in there. Okay? We'll make sure we cover all those basics. I am going to do one thing different this year that's based on my advisory committee. Before, I've always had my students working with a client so that you get that presentation stuff that you have to do. We can't get that in 6 weeks anymore. So this time, I'm going to basically cut the client out of the picture. Now, in essence, it's going to save us a week worth of work. In the architectural world, the design of a structure takes forever. Okay? And it's no different. In fact, residential is probably some of the worst. It's easier to do a building like this than it is to do somebody's house. Okay? Because then you're dealing with multiple personalities, people that are feeling it coming out of their pocket. They're watching you like a hawk, I guess might be the right way to say it. And then the worst part is you get in and you start talking trim and color and these types of things, and you can bog down for years. You really can. I swore 3 years ago I did a structure for one of our local engineers, and after the 12th revision I swore I'd never do architectural drafting again. The 12th house, and it was just a nightmare. So it can be that way. It also can be fantastic. If you get somebody that has deep pockets and they want to do some trick stuff, it can be real exciting too. Now, if you're working in that field, you're probably working for an architect where you're doing schools, office buildings, hospitals, these types of things, and you don't get that client mix. That's such a tough deal to deal with when you're dealing with a private industry. But we'll explain that more. In essence, you're going to do an entire residential structure, and your drawing should be good enough to get it permitted and start building on it when we're done.
So we get to design our own, because I understand we have to do something.
No, you're not going to get to design your own because nobody pays you to design your own home.
Not for the class, though. Then what if you cut out the person, then
That's one of the hardest parts of these, especially architectural, is, your thoughts really don't count.
I know.
Really, the hardest part is getting into the mind of your client. Because you may love a mudroom, but your client absolutely doesn't want it. Okay, so you've got to learn right quick that, hey, if I keep pushing this one item and that person doesn't like it, you're probably going to be out of a job very quickly. That's one of the hardest parts, is getting into the mind of your client. And we'll talk a lot about that, because you're designing for them. We all want to design our own home. Everybody does, I think. But nobody's going to pay you for that, right? And we've got to work on the other arena where we are providing a service for financial benefit. Then we'll go to the civil industry. The reason we're going to do this one last is this one will have the most outside stuff going on. Because we do need to get outside on this one. Most people don't know what civil is. Civil is anything that has to do with the public. So in essence, sewers, transportation, bridges, power. You think power is an electrical thing? It's not. It's a civil thing. There's two different breakdowns of it. The generation and distribution of power is a civil industry. You might think of these guys as, you've heard the saying, jack of all trades, master of none. That's many civil engineers, because they are so broad. It's our largest engineering field by far. There's nothing that even comes close to it. But anyway, we'll do surveying in that one. So here's where you also learn how to run a total station. You're going to learn how to run GPS surveying, and then bring that information back into the room so that we can use it for design work. And we will focus a lot on facilities and transportation, because that's where most of the employment is. So that's going to end that semester. Now, there is one other course on here some of you have to take, Trig for the Trades. This one is Thursday afternoon, 2:30 to 3:30. It's a 1-credit course. You take it in here. It's an applied math. I'll teach it to you. There is a book, but you do not have to buy one. Okay, we give it to you. Okay. It's a good course. It's something that I think is pretty mandatory if you are ever going to get past a drafter level. If you have desires to go to a designer level, then you need that math. There's 2 maths you have to have. You got to have geometry. That's what we're doing, right? That's our main math. But then trigonometry is also one that solves a huge amount of problems for you. It's my favorite math. It solves more problems for me than anything. It's harder to say trigonometry than it is to take the course. It's not hard. That's a $10 word, right? Trigonometry, that's what we call it, trig. It's not really, I don't think, in my mind, a terribly hard course, but it's a beneficial one.
Is it based on like calculators, shapes?
Yes, you'll have a calculator. It's an applied. Just so you know, on that course, you're not going to do a single proof then. So if you take math, you probably spent a lot of time doing a proof to say this is why this equation works, and you had to go through all the proofs of it. We're not going to do any of that. We're going to say this is right angle trigonometry. It works. Here's how you use it. This is the law of sines. This is the law of cosines for oblique triangles. These equations work. Here's how you use it. That's in essence what that course is going to be. Any other questions on these? One other thing I think quite a few of you are probably wondering about is there's a course out there called DRAT 285. And it stands for Co-op Education. What is this course? And let me give you a little background on this. All technical programs may count up to 25% of their credits with on-the-job training. Okay, so that's everybody. That's the welders, that's the cabinet makers, it's the HVAC people, it's us. If you take your credits for a degree, which are 60, times that by 25%, you're going to come up with 15 credits. So you can actually work and have that work count for up to 15 of your credits. Now, when we get through about halfway through this guy, and this is going to occur somewhere in the beginning of March, you will only have 14 credits left. So in essence, you could leave here and go to work in March. You no longer have to be in the classroom. Your employer is taking over your education. I will then take the hours that you work, you still have to pay for credits, and then I will substitute that work experience for drafting 152 civil, and then the summer semester, which is mechanical engineering, is 4 credits. We have a programming course for 2 and structural for 2. That's 14 credits. And I can substitute your work history in for those. Now, there's a couple reasons why a lot of people take advantage of this. In the drafting world, we have 2 hire cycles when firms are really staffing up. The first one and the biggest one occurs in the spring. This is as firms are coming out of winter design, they're getting ready for the summer construction season, they know their staffing needs and they react accordingly. So that February through May is a huge hire cycle for us. Now, if you had to stay here for coursework, you miss that cycle, because you guys technically don't graduate until July. So you can leave during there and go to work. Do I agree with that or not? To tell you the truth, I'll be flat honest with you. You will always learn more in the workforce than you will in any education facility. You always will. And there's a simple reason. You're at it 8 hours a day, and I don't have a stick. I can't fire you. And there's nothing like having that stick to keep a person motivated day in and day out. Not to mention they're working on multiple projects at the same time. See, I really think working in the work world is probably the fastest way to learn. Now, there's the other thought of this is that when you do the education realm, you learn the theory in the background, right? We spend a lot of time doing DSFs and really kind of concentrating on these things in the back that make you a good drafter. In the work world, you probably won't get that. Yes?
Do they, as a work world, do they look in here to hire us knowing that we're not finished?
Oh, yeah.
Because they want to mold people?
Yep.
Okay.
They want you. As soon as you finish this guy right here, as soon as you're done here, folks, you're ready to go to work, in my mind. It's, you know, not everybody is. You got to make the transition from theory to work, right? And there's a big transition there. But employers come in if they're going to hire you, I have a conversation with them and say this person hasn't had mechanical, or they have, but they haven't had the specifics of it. They haven't been through the civil yet. And the employer says, okay, we'll take care of that. We understand they don't have those skills, we're going to train them up. And they'll train you right there on the job. They can get you doing what they need to do. So there's kind of caveats to both methods. I think some of you, you're ready to go to work. Some of you, I would probably sit there and say, you know, you would probably benefit from another month in here, or another month and a half. That would be my opinion. Ultimately, you need to make that decision. Now, as far as your degree goes, as long as you've gotten only 14 drafting left, then you're still going to graduate. This does not apply to any academic course. So if you've got a speech hanging out there or something like that, that is outside of this realm. That draft 285 will not count for any academic course. Hey, that's why we're kind of pushing with a lot of you saying, hey, you got to get these academics done. Boom, boom, boom. Because they're going to limit what you can do on those. Yes, Joe?
Do you end up with W's on your transcript?
No, no. You actually, it's got a P. It switches to a pass-fail. Okay, instead of a GPA, where you would get an A, B, or C, or D if you stuck in those. And pass-fails don't really count into your transcript as far as GPA. Yes?
If you this is just a FYI, if you transfer to some colleges, they will convert pass-fail to a C. So it can affect your GPA down.
Yes, at that point it probably would, if you wanted to let it go on. Now, that's really one thing to keep in mind on that. If GPA is a concern of yours, 2 things I'd say on that. One, I've never had an employer ever ask me what my GPA was in college. They just said, did you get your degree or didn't you? That's the only question they ask. They also don't ask, did you go to Yale or did you go to CSI? They don't care. They don't care one bit.
Because Yale at more higher, you can expect to have more pay.
Yeah, because I'll be honest with you folks, you've got a whole nother education starting when you leave here. You've got to prove yourself. You've got to work and prove yourself. And I'll tell you what, A hard worker, a dependable worker, regardless of their skill level, is somebody that me as an employer, I would love to have that. Because that's a person that's going to learn. And to be honest with you, what we're giving you here, that's the platform. But when you hit industry, you really don't know anything. And you're gonna hear me say this when you get to these places, the smartest thing you can do is first 6 months on the job is keep your mouth shut. It is. Nobody cares what you think. They don't. You sit there and you absorb, okay, and you learn. You'll be given the opportunity to grow and have a say in things, but it's not right away. You're going to be dealing with people that have 40 years building experience, 50. They've forgotten more than you even have an idea what's out there. Okay. What they want is a good worker. Somebody that's going to be a team player, will be dependable. We'll give you the platform, but I think Aaron said it maybe from TNT the best last year when we toured them. He said, hey, you come in here with the platform, but I need you to be hungry. I need you to be hungry for knowledge because your education is really just starting. Okay? Nobody knows it all. Be flat up, nobody knows it all. It's are you willing to learn? And I hope you go out with the attitude, I'm going to learn till the day they put me in a pine box. Because your life's probably pretty boring if you aren't with that attitude. And really, that's the way it is. But anyway, be that as it may, if you want to be going to work, we're going to start having employers come in here about February. And you want to get the interview process started about February. If you've never applied for a professional job, these interviews don't, it's not like I'm a framer or a concrete worker. I show up on the job site with a set of tools and I say, hey, I want to go to work. And they say, okay, get over there and start humping. And we'll see how you do. These interviews might go to 2 or 3. You're dealing with people that are traveling around the world on design projects. They may be out of town for 3 weeks, so you get an interview and then you don't hear anything for a month. It's because the people doing the hiring are not here. It takes a while to get through this process. We've had it take 2-3 months to get the first job. So we'll look somewhere around February. Now, one other thought before I go to you, Cheryl, is if you don't know how this process works, we're going to give you a free course that's going to start early February. It's job training, and in essence, a guy from over in the workforce development, Thomas, comes over here. He runs out how to write a resume, how to do an e-resume. They run you through interview process, how everything's going to work for these types of jobs. And we do mock interviews and things like that to give you a little bit of practice. Because in an interview, you've really got about 3-4 minutes to really make your case. I mean, when I was hiring and firing, I knew in a couple minutes whether a person was going to fit or not. I still remember the time a guy showed up to get a job with us up with Hecla. And he showed up in a 3-piece suit, and it's the middle of winter. The first thing I did is start laughing and said, let's go to the pit. And we went out there and, you know, mud up to our thighs, and got a flat tire, and we had to fix that. I mean, it's just kind of ridiculous. You got to kind of know a lot of other things besides that. I mean, the guy should have shown up with work clothes, as opposed to, he wasn't going to be an office worker, he was going to be a mining engineer, which is a different game.
Did you hire him?
No, heck no, I knew I wouldn't hire him right off the bat.
You got him good.
Yeah, I just had some fun. Anyway, be that as it may, this is what's going to go on. We will give you a class on doing that, okay? And it's free, by the way. You won't get anything for it saying you did it, but it's free knowledge. Okay. Cheryl, you got a question?
Did you say there's another hiring time besides the spring?
Yeah, it happens in the fall. There's another one that usually goes on around August, September, and that's as firms go into the winter, they're being hired for the next year's jobs, and they know how many people they need over the winter to get the work done to be set up for the following spring. So now, you can get hired any time of the year. I don't want to quantify that. It does happen all year long, but those are the 2 big times. I mean, in May, I'll bet you there's probably 200 or 300 people drafting wise in the state of Idaho that'll be hired. Come in the fall one, maybe 100.
So they laid off continuously? I mean, you say there's a big wave. Are they just hired for the season? It's like a seasonal worker?
No, these are full-time employee jobs,
Huh?
as a general rule. Because drafters, once you get hired out at entry level, you're going to be changing jobs. I mean, there's a lot of drafters out there that after a year on the job, they go to the surveying field. We'll have Tom Ruby come in, which has a drafting degree, and he's probably the lead surveyor in the state of Idaho, and works over here for JUB. But he went that realm. We have others that move to the designer level. We have others that go back to school. I know many of you are thinking, hey, I'm going to get a bachelor's degree, so you're leaving the field also. Yeah, so there's that. There are those opportunities. Not to mention, you know, Idaho is what the fastest growing state in the union right now. Okay, and we're bringing tons of industry in and all those jobs that come with it. Yeah, unfortunately, some of us think that way. I mean, I'm with that. I like my small town.
Me too.
But they're still small areas, we can still get there.
Yeah.
So in essence, any other questions on these? Okay, so keep in mind, if you are itching to go to work, there is that option for you out there. One last thought on this. You know, I kind of said, is it good or bad? I don't really know. Last year, I had every single student took advantage of this. I have gone into the summer. One year I had 19 students, one of my first years. I went into the summer with one student. Everybody else took off and went to work. I think as far as the student population goes, many of you are pretty hungry to get out there and get started. And I know it's kind of sucks living on top ramen and peanut butter that most college students have to deal with, and you want an income. So that might be a driver for you, whatever the case might be. Like I said, all of us have to make that decision ourselves. But I'm certainly could weigh in on it, and use my opinion in making your decision. I think you're going to have a good job market this year. Last week alone, I got 4 emails from employers. Who you got? Nobody. come back here in February, and we'll be able to throw some people your way. Okay, so it's looking like you're going to have a great job market. Now, if you're going to stay local, there's only going to be so many of those. But if you're willing to travel, I don't envision anybody having a problem getting that first opportunity. Any questions? All right, before we jump into stuff, I was going to do some specialty shapes. I'm not going to do those unless given an opportunity next week. But you do need this for one of your drawings. When we do some special shapes like tapers, irregular curves, slots, things of this nature, they have special dimensioning techniques. So I want to point you to this figure. I'm on figure 1730, and I'm not going to talk about this in a huge amount. We'll come back to it if we get a chance. If you look at these dimensioning techniques for slots, right, and what we're talking about here is just this feature, this one, this one, this one. You dimension on one of these 3 ways, and it's based on the construction methods used to complete these shapes. If you look at these, they're all double dimensioned. By that, there are redundant dimensions in them. And it's based on how we build them. So like on this one, where I've got the width of 10, I've got the radius, but then I've also got this length here. Well, I don't need that whole length, right? Because I should go really, I would do it from center to center, and then 1 radius instead of both of them, then you would be done. Now on this one, they give you too many of them. The radius here is double dimensioned with the width, right? So normally we would take one of those 2 out. 4 slots you don't. This is really probably the one that's used the most, the center one here. And this is built on a slot being done with a router. If you don't know what a router is, it's a device that's got a drill or a cutting edge that you drop down in, and then it can cut linearly too. It's a lot like how a CNC mill works, except you're running it by hand. So here we need center to center to drop our bit in, and then we cut the trench this way. We need this size because it matches up with our bits, or this one, okay, the special devices that do. So this is kind of the main one most people use. If you don't have a lot of room, we can go to leader lines for basically the same information, where this is giving width and length, and this is also giving width, but it's also calling out a device. Because I can build this a lot of different ways. I can cut it with saws. I can then drill just the ends, or I can use router devices, I can use CNC. So use one of these three when you dimension your slot. We don't have any of the other specialty shapes in our drawing assignments that you're going to come across until next week. So I just wanted to point that out. I think this is drawing 5, right? Or 4B, one of those two? The slot, 4B. 4B. Now the other thing we're going to come across is threads. So I'm going to move right to that. Let's do the definitions of threads. We'll take a slight break and we'll come back and draw some. So first off, when I'm talking threads, okay, this guy here, here's one of them. This is what we would call an external thread. Many of you know it as a bolt. One of the 5 best inventions of all time in my mind. Ranks right up there with a wheel. You cannot do these, any discipline, without knowing these things. So if you look at this one, this is called a cap screw. It's not really called a bolt. It's called a cap screw. Now, they're all built proportionally. Remember we talked about Henry Ford, which I have come to find out is not the first person. Thank you, Andy. It's Eli Whitney. And by the way, I did read a nice article on him. And I watched the 60 Minutes deal they had on him also. The assembly line, where we standardized parts. These things are standardized. They have been set up to where we can use them in multiple devices. When we're dealing with a cap screw like this one, okay, the distance these threads come from here to here is proportional to the diameter of it. This open shank right here is proportional to the open diameter. This hex head on the top is proportional to the diameter. It's all done off of proportions. So therefore, we can just give a recommendation or an approximate shape and then give them the thread note, and they will be able to get the right device. So this is an example of a cap screw and what's going on. There are 2 types generally. There's a lot of specialty types. This is a cap screw. There's